On May the 6th, 1954, Roger Bannister, a 25-year-old medical student, shook the world by breaking what had seemed an insurmountable athletic barrier. Bannister had run the last lap in 59.4 seconds, and it was more than enough to give him the record, 3 minutes 59.4 seconds. No one had beaten the 4-minute barrier before. It was a great performance, and done in the days of cinder tracks, spikes and training bouts between studies. Guts and grit in true amateur spirit.
Okay, 2014 problem 5 for BC only. Let R be the shaded region bounded by this graph, that line, and the vertical line x equals 1. No problems with the limits of integration or anything like that for anything you're going to do. It'll just go from 0 to 1. Find the area of R. At this point, you have to actually compute the antiderivative and get an answer. At this point, I write the plus c just for completeness and so that I don't write anything false, but I'm not actually going to use the plus c. I'm just going to sub back in for u in this expression and carry on. For part B, write but do not evaluate an integral expression gives the volume of the solid generated when r is rotated about the horizontal line y equals -2. I think it should be noted that the scale is a little strange on the picture. If you go 1 to the right, the slope is -2 on this line, so this is actually the point 1, -2, even though it doesn't look like it, but that's not any problem. So that means that y equals -2 is your line about which you're revolving the figure. And this is where you need to establish radii. So there will be, for the entire interval, an outer and an inner radius. Here's the outer, and here's the inner. For part C, write but do not evaluate an expression involving one or more integrals that gives the perimeter of R. So this will be the length of curve formula for this portion. That means you're going to need the derivative of that first function. Here, if you plug x equals 1 into the function, you would get 1 times e to the first. This portion, I think I already discussed, has a length of 2, since obviously there's no negatives for length. And then this will need a Pythagorean theorem, but it's just 1 squared plus 2 squared equals x squared. So that should be the square root of 5. And again, let me get to the derivative here. No great need to simplify that. That's it.